In this video, we are going to do everything involved with an ellipse. We're going to take a general equation that you see there, and we're going to complete the square to get one of these standardized equations. And once we get one of these standardized equations, then we're going to identify what the center is. First of all, whether or not it's a horizontal or vertical ellipse. Get the center, get all four vertices, get the major and minor axes length, and get the foci. Okay, so let's just get started on this one. Now, again, different textbooks give different presentations. What I'm used to teaching is this is always true, that A is always bigger than B, and then you have two different presentations. If your larger denominator is underneath the x term, you will get a horizontal ellipse. If your larger denominator is underneath the y term, you will get this vertical ellipse. Okay, so that's the presentation that I'm going to be using. All right, so the first thing we want to do is complete the square here if we just have this generalized equation. So I'm going to put the x terms together. And then leave a bit of a space. And then I'm going to put the y terms together. A 54y. And then leave a bit of a space. And then I want the constant over on the other side, so I'm going to subtract 61 from both sides. Okay. Now I can factor out a 4. I could also factor out an x, but we're not doing that. We're just going to factor out the largest number that they have in common. And we're going to leave a bit of space. And then the largest number that these have in common is a 9. Then leave a bit of a space. Okay, now we're going to start completing the square. And the way you complete the square is you look at this term and you're going to divide it by 2 and then you're going to square. So I'm just going to write SQ. So negative 4 divided by 2 is negative 2, and negative 2 all squared is positive 4. Now what you do to one side you have to do to the other, but wait, don't do that because that's not right. You have not added 4 on this side. What you in fact have done is you've added 4 times 4. You've added 16 on that side. So you have to do the same thing over here. And now I'm going to come here and I'm going to complete the square. Same thing. You take that number, you divide it by 2, and then you square it. So 6 divided by 2 is 3, and 3 squared is 9. But what you do to one side, you have to do to the other side, and I have in fact added 81 to this side, so I have to add 81 to that side. Okay? So, now I can get this looking a little bit better. 81 and 16 is 97, and then minus 61 is 36. Okay, so all of that's going to be 36. Okay, now, in completing the square, this little operation up here, I can write it like this. So what goes in here? Well, it's going to be whatever that is divided by 2. And negative 4 divided by 2 is minus 2. What's going to go in here? It's going to be this number divided by 2. And 6 divided by 2 is plus 3. Okay. Now I'm nearly there. I need to have a 1 on the right hand side. So in order to do that, I need to divide that by 36. But what I do to one term, I have to do to every term. Okay, so then that's going to bring us up here. I'm going to have x minus 2 all squared divided by, now 36 is 4 times 9, so the 4's will cancel and I'm just going to be left with a 9 there. Then I'll have plus And 36 is 9 times 4, so the 9's will be canceling, and you'll be left with a 4 in the denominator. Okay, so we are practically there. I mean, a lot of books would stop here and say, well, that's your standardized formula. Okay, fair enough. But if you want to read off, if you're asked, like, what is the center and other things, it just might behoove you to rewrite this y plus 3 as y minus negative 3. So y plus 3 is the same as y minus negative 3. And so when I have it like that, we can begin to see what our h and our k are going to be. And also, we can see that that's our larger term in the denominator. So out of the two denominators, this is the one with the largest term, and it's underneath the x term. And so we are going to be having the case of a horizontal ellipse. So I might even want to go further now, and instead of 9, I'm going to write that as 3 squared, and instead of 4, I'm going to write that as 2 squared, because now I can just see what everything's going to be. It's x minus h, and so h is 2. It's y minus k, and so k is negative 3. And A is going to be 3, and B is going to be 2. And we're going to have a horizontal ellipse. Okay, so the center is HK. And that's going to be 2, comma, negative 3. Okay, so if I'm going to draw this, I would have, say, a 2 there, and a negative 3 would be there, and that's going to be the center. Okay, now since it's a horizontal ellipse, my two major vertices are going to be A units to the left and the right of the center. So 3 units to the left and 3 units to the right. So 3 units to the left. So I'll have 2, so that'll be a negative 1. So 3 units to the left. I might have to. So negative 1, comma, negative 3. That's one vertex, major vertex. And the other one's going to be 3 units to the right of the center. So 2, 3, 4, 5, and so this vertex would be 5, comma, negative 3. Okay. Now what about my minor vertices? Well, that's where B comes in. It's going to be 2 units up or 2 units down from the center. So if I go 2 units up, so 2 units up would put me here at negative 1, sorry, at 2, comma, negative 1. And then 2 units down would put me here at 2, comma, negative 5. Okay, now that I have the vertices, I can start to draw this football shape. Okay, I can. And so my major axis, or my major radius, is 3, and so the length of my major axis would be 2 times 3, which would be 6. So that has length 6. And my minor axis, well, the radius or the length from the center to each minor vertex is, each minor vertex is 2, and so my minor axis would have length 4. Okay. Now what else could you be asked for? You could be asked for the foci. Now the foci are not on the ellipse. Like, the only points that are on the ellipse are my vertices. The center is not on the ellipse. But my foci are like going to be around here. And I use a new letter called C to get where my foci are. So C, let me do this in black. C squared is A squared minus B squared, always for an ellipse. And so A squared is 9, B squared is 4. And so if I take square roots of both sides, and C is a positive number because I'm talking about length, about distance, it's going to be the square root of 5, which is going to be a little bit more than the square root of 4, which is 2. So that's going to be a little bit more than 2 units. So one foci is the square root of 5 units to the left of the center, which would be somewhere over here. And so one focus, the left one, so I might do FL, is going to be 2 minus square root of 5, comma negative 3. And then my right focus is going to be square root of 5 units to the right of the center, which is going to be about here, a little bit more than 2 units to the right. And so that's going to be 2 plus the square root of 5, comma negative 3. Okay, now I've done all of that, and luckily enough I do have the answers where we can check it. So I'm going to do 2 examples in here, and if we keep scrolling down, the example we've just done is the one on the left column. So on the left column you can see we got the correct formula, we got the correct coordinates for the center, and the correct length for the major axis. It's going to be 2 times 3, and the minor axis is 2 times 4. We got the coordinates of the vertices, the major vertices and the minor vertices correct. We got the foci correct, and we got their coordinates correct. And if I keep scrolling down, this is the actually how it looks. And I think that you'll agree that what I did with my sketch, while it wasn't, you know, the greatest drawing, it was still accurate. That is an accurate sketch. Okay. So we're going to say bye-bye to all of that, and we're going to look at this second example. We're going to do this one. And again, I've got all the answers already worked out, but let's just go through it from the start. Okay. So we've got a new one. All right. And let's get started with this one. Okay. All right, so same thing. I'm going to put my x terms together. Okay. I'm going to leave a bit of a gap, and then I'm going to put my y terms together. And I want to get my constant to the other side, and so what I'm going to do, okay, let me get rid of that, is I'm going to subtract 1 from both sides. Okay, now I'm going to complete the square. No, I'm not. I'm going to factor out. With this, I can factor out a 16. And that'll leave me with x squared minus 4x. And then I'm going to have a gap. And with these, I can factor out a 9. That'll leave me with y squared minus 6y, and again I'll leave a little gap, and then equals negative 1. Now I'm ready to complete the square, and the way I do that is I'll take this, divide it by 2, and square it. So negative 4 divided by 2 is negative 2, and negative 2 all squared is positive 4. But what I do to one side, I have to do the other. I'm not actually adding 4 to both sides. I'm adding 16 times 4. And I'm adding 64. Okay. And now I'm going to do the same thing to this. I divide it by 2 and square it. So negative 6 divided by 2 is negative 3. And negative 3 all squared is positive 9. So I'm going to add 81 to both sides. Okay. So, what have I got over here? 64 and 81. And then minus 1 is 144. Okay, and then I've got this. I can write this now because this is by design. This was the whole purpose of completing the square. So, what's going to go in here? This number divided by 2. And negative 4 divided by 2 is negative 2. What's going to go in here? This number divided by 2. And negative 6 divided by 2 is negative 3. Okay. Now, you can see, regardless of the equation, it has a 1 on the right-hand side. So, to get a 1 on the right-hand side, I need to divide that by 144. But what I do to one term, I have to do the same thing to every term. Okay. Now we're getting very close. 144, most students know that as 12 squared, but that's not useful here. 144 is also 16 times 9. So if I rewrite 144 as 16 times 9, then the 16s go away, and I'm left with a 9 in the denominator. And again, if I rewrite 144 here as 9 times 16, the 9's cancel, and I'm left with 16 in the denominator. Now, my larger denominator is underneath the y term, and that's going to give me this second box here. I'm going to have a vertical ellipse. All right. So what I might do now is I'm going to come up here, and I'm going to write it as x minus 2 all squared, and then instead of 9 I'm going to write 3 squared, and then instead of 16 I'm going to write 4 squared. Okay. So this is the form that we're in. Okay, so now I'm going to make some room over here. And we'll get all of the rest of the stuff. It's going to follow very quickly now. So we just need to identify our H and our K, our A and our B, and then we can get this thing started. So again, in a different color. My H, it's x minus h, so the h is 2. It's y minus k, so the k is 3. And the A is 3, I'm sorry, the B is 3 here. The A is the bigger one. The A is 4. A is 4 and B is 3. Okay, so my center, again, we're going to have a vertical ellipse. The center is going to be h comma k, which is going to be 2 comma 3. Okay. So again, I'm just roughing it. There's my center. Since this is a vertical ellipse, the two major vertices are going to be A units above and below. So my major vertices, I'm going to have the same x coordinate, but I'm going to go 4 units up. So 3 plus 4 is 7, so 2 comma 7. And then 4 units down. And so 4 units down, 3 minus 4 is going to be negative 1. Should be about there. Okay. And so my major axis is going to be the length of this red line. And the red line is, each of these segments is 4. And so my major axis would have length 8. Okay. I have 2 comma 7 and 2 comma negative 1. Now, My minor vertices are going to be B units to the left or right of the center. So I'm going to have 3 units to the left or right of center. So 3 units to the left of 2 comma 3 is going to be negative 1 comma 3. Right. And 3 units to the right of 2 comma 3, so 2 plus 3 is going to be 5 comma 3. And so my minor axis would have length 6, because each of these segments would be 3 units long. Okay, now I have my 4 vertices, so I can start to sketch this thing. Okay, again, it's pretty rough, but everything I'm drawing here is accurate. All right, so making allowance for the fact that it's freehand, everything I'm drawing here is accurate. Okay, and then the only other thing I need are the foci. The foci are going to be on the major axis, right, somewhere around there. I have to get C. So in this case, it's going to be a squared, which is 16, minus b squared, which is 7, and so c is going to be the square root of 7. So the foci, since this is a vertical ellipse, are going to be the square root of 7 units above and below the center. And square root of 7, again, 7 is less than 9, so the square root of 7 is going to be a little bit less than 3, but it'll be bigger than 2. Okay, so it's going to be 2 comma 3 plus the square root of 7. So the top one is 2 comma 3 plus the square root of 7. And then the bottom foci there is going to be 2 comma 3 minus the square root of 7. Okay, so that's everything for this one. Now let's check it. And this second problem was the one in the right column. Okay, so we got the correct standard formula, we got the correct center, and we got the correct lengths. The total length would be considered a diameter. Okay, so 2 times those. We got our major vertices and our minor vertices correct. We got the focal distance correct. And we got our coordinates for the foci correct. And then here's the drawing. And you can see that it does look like what I sketched. What I sketched was accurate. Now the only points that are actually on the ellipse are the 4 vertices. So the center is not on the ellipse and the foci are not actually on the ellipse. Okay. So I hope that these 2 examples helped you. Okay, so we went through each of them, excuse me, and we did everything that you could possibly be asked. So I'm going to stop the video there. Thanks for watching.